Hey, Jack.
Hello.
How was your break?
It's all right. Yeah.
You stay here, go anywhere, and just like.
San Diego, a day or two.
Yes.
Yeah. I'm gonna extend the homework to be due on Wednesday.
Okay, we were struggling a little bit.
Yeah.
That's why we showed up a little bit early.
Yeah,
I'm
yeah,
just
yeah.
I was having trouble just getting it onto GitHub because of mostly like I'm getting a lot of await and void errors. And so I can't push it with
Yeah.
like those, like I understand how they work. It's just like I don't, sometimes it's just really slow with them.
Yeah.
But
We can take a look right now.
yeah, that sounds good. It was definitely fun, challenging, but challenging. Yeah, I learned a lot doing it, but
Yeah,
I
it's
executed.
the first time, so it's you'll get more chances to homework 6. You'll do like more or less the same thing.
Wait for a couple more minutes for people to join up, come in. And for everyone who's panicking, I'll make the homework due on Wednesday instead of today, so. And we'll go over the homework assignment on Wednesday. Today, we're gonna talk about, briefly talk about homework 6, which is due 1 or 2 weeks from now, I forgot. 1? Yeah. Okay, maybe I'll make it 2, actually. And then, wait, so is it due next Sunday? I totally forgot.
That's due.
Oh, 20, oh yes, I'm totally dumb. Yeah, I'm gonna extend that maybe by 1 more week. Yeah, we're gonna briefly talk about this one and then contract security. Wednesday we'll go over homework 5. Yeah. Let me shut the door. I have to prop it open because it smelled like sweat. Okay. Okay, let's talk about homework 6. So homework 6 will be more or less the same as homework 5, only in this case, you get to write the smart contract plus the testing script. So I call it half stack because usually when people say full stack, when people say they're a full stack developer, it means they know how to create an entire web application starting from the backend server database all the way to the front end. But since we haven't learned how to do web stuff yet, so right now what we know is we know how to write smart contracts, we know how to write testing scripts, which more or less are they're basically front end codes, but we haven't really learned how to do front end yet. So we're currently like half stacked developers, not full stack. So the contract that you're going to write is it's a platform called dBay, totally original. It's an auctioning platform, basically eBay, but massively simplified. So basically, I mean, I guess everyone knows how eBay works, right? More or less. Okay. So eBay basically is so anyone's able to start an auction, and any auction has certain attributes, right? And then anyone can start an auction. Anyone else can bid. You as the auction initiator cannot bid on your own auction, right? Whenever someone tries to make a bid, it must be higher than the current bid because it doesn't make sense to bid the lower amount. And whoever gets outbid, they have the option to retrieve their funds, right? And by retrieving their funds, it basically means, it doesn't mean getting the funds back into their wallet instantly. Rather, we can keep track of how much they have in our smart contract, and they're able to withdraw their funds separately later. So let's say we're bidding for. Oh, actually, I'm actually selling my old laptop. It's an M1 Air. Let's say I'm auctioning my M1 MacBook Air. Okay, let's say the starting price is $600. Okay, that's a bit too low, but Apple gives me $640 per trade-in. So $600 starting price, and let's say Nicholas bids $610, and then Chase bids $620, right? So in order for Nicholas to bid $610, he has to have $610 worth of Ethereum deposited into the contract. But when Chase bids $620, the $610 is returned to Nicholas, but it's not returned to his wallet immediately. Let's say, what if he really wants my MacBook for some reason? And he wants to basically add some more money to basically outbid Chase. Well, in that case, if we force Nicholas to withdraw his $610 back to his wallet, and then he has to deposit $630 again, it's a bit inefficient. So we keep track of how much he has in the smart contract. We'll just say that we'll just internally keep track that he has $610. So he has the option to either withdraw all of his $610, or he has the ability to maybe deposit $20 more and bid $630. Okay, if that makes sense, that kind of. So basically, you have like another wallet or your own balance inside of the smart contract. Okay. And yes, and every bid has a deadline. It's a timestamp, which I'll talk about today. And once an auction is past the deadline, nobody can bid on the auction anymore. But anyone's able to settle it, and by settling, it's really nothing complicated. It's basically emitting an event, declaring the winner, which is the highest bidder. Okay. And nobody can do anything when the contract is paused as usual, right? And you're given a list of, so you're given this, you're given some skeleton code, all right? And I have outlined the point distribution for your Solidity, the different functions. So you've got start auction, and you have two bids, right? The reason why you have two bid functions is that the first one is for when you don't have any balance. So you want to bid, let's say when Nicholas is bidding 610 at first, he doesn't have any balance inside the smart contract, so he has to call the first bid, right? But when he's calling the second bid, well, he already has 610 in the smart contract. What he can do is he can call deposit to deposit $20 more, and then call the second bid to bid 630 because and now you notice the second bid function isn't payable because then we're not really we're kind of just grabbing money from the existing balance instead of Nicholas sending 630 over from this function. Okay, and yeah, let me know if you have any questions. I'm gonna again push the deadline back by another week. So instead of March 28th, it's April, I don't know, 3rd, 2nd, I don't know. Okay, and then again for functional tests, you got to write 2, right? So no more unit tests. Functional test, basically one that walks through the program. Ideally walks through like an entire auction, making use of all the functions normally, so no monkey business. And the second time you want to try to break as many things as possible and see if your contract stops you from doing it. Okay. Any questions on homework 6? I think it's relatively straightforward.
Could you explain one more time the difference between the two bid functions?
Okay, so let's say, so this one, the first bid, you're basically sending some ether alongside the function call. So let's say when you're trying to submit your first bid, $610, right? And at that time you don't have any balance inside the smart contract, right? So that would be a mapping already giving that away. And in that case, if you don't have any balance, then you would have to send money over because you don't have balance in the smart contract. But let's say Chase outbids you 620 and then you try to bid 630. And what you have to do is you have to deposit $20 more worth of ether, and then call this bid instead, because now you're making use of the existing or the refunded $610 because you got outbid.
Okay,
If that makes sense.
so for like, after your first bid, you're using the deposit, the second bid
Yeah,
function.
like
and then the first
so
deposit.
you can still use the first bid if you want to just deposit $630, but then your $610 is still sitting in the balance.
Gotcha.
So it's totally up to you, but I'm just offering like 2 choices. I just noticed I might have missed a function, but that's fine. It's really simple. Basically to get the auction struct. That's fine. Okay, any other questions? No more. Okay, it's fine. You can still ask questions.
Are there descriptions for each of those functions? Or?
They're in the skeleton code.
Oh,
Yes.
cool.
Yeah, let me actually show you. Let me get to GitHub. Are we able to see this? No. So you do have the comments for each function, okay? So it tells you what to do, what to check for, and basically what things are. So let me know if they're not clear enough. You've got 2 weeks, okay? And if you're not really sure how to write the functional tests or whatnot, you can still start on the solidity part first.
How does block dot timestamp differ from like block dot height or block dot number?
It's the same thing.
The same thing.
Yeah.
Okay.
Yeah, you just have to like it just depends on what's more convenient for you to use, because usually let's say when you look at the clock, I don't tell you how many seconds have passed since 1970. I tell you at the time. So the same thing, right? I don't tell you, the height of the block. Rather, if you prefer a more friendly format, it's just timestamp. But you can look up if you're given any block number, you can look up the timestamp for it. So
Okay.
Yeah.
Would you, I don't know right now, like eventually ever go over like how to incorporate like block height or number into testing? Because for the homework previously, for like the extra credit, we had to include a deadline. I found it hard, not a little bit confusing to write functional tests that incorporate a deadline and like being able to test block height while like running it.
Yes.
manually.
yes, we can talk about this. I'll actually make a Piazza post on it. I think I meant to make a post on that, but I forgot. But I'll make a post.
Cool,
It's
yeah,
very-
that's super helpful.
It's very simple. You're able to force the local EVM to mine more blocks.
Okay.
So that's homework 6. And let's get back to what we're gonna talk about today. Okay, contract security. Interesting stuff. Okay, so now we're talking about, now we're gonna learn about all the ways that people can screw with the contract. And why basically coding in Solidity is, it's just full of traps, So the first one is underflow, overflow. We briefly talked about this. If you guys remember, if anyone remembers, feel free to, just take over this part. If no one remembers, that's fine. So basically, let's say in a system of unsigned integer, it doesn't matter, let's say uint4. So the max value of uint4 is 2 to the 4th minus 1. So that's 16 minus 1, which is 15, right? So a system of uint4 can only represent numbers from 0 to 15. So what if I do 1 minus 2, right? Well, 1 minus 2 obviously is -1, but in this system, there isn't any -1, right? Because the range is outside the range. So what's going to happen? And the same thing with 15 plus 1. Well, 15 is the max value. So what happens? I mean, 15 plus 1 obviously gets you 16, but it can't be represented by uint4. So what's going to happen is 1 minus 2 will become 15. Okay. So 1 minus 2 becomes 1 minus 1 minus 1. I hope everyone can see that. And then 1 minus 1 is 0. 0 minus 1. Well, you can't go under 0 anymore because that's like the bottom of the range. So it just wraps around to the very top. So 1 minus 2 equals 15. And similarly, 15 plus 1 is going to be 16, but then it wraps around again. So it goes past the max value, wraps around to the minimum value, which is 0. All right. So this is something that you have to watch out for. But if you took this class, which you have, and if you use a compiler version above 0.8.0, the compiler actually checks for you. So the check is very simple. And then there's also another library called SafeMath. And it's very simple. It basically checks. So when you do 1 minus 2, right? A minus B equals C. Let's generalize it. It basically checks if C is larger than A. And if the number that you get from subtracting 2 numbers is bigger than the first number, then it's an underflow has happened. All right, so it's gone under and wrapped around. Okay, and similarly to check for overflow, you just check if the sum is smaller than either of the 2 numbers that you're adding. Okay, if it's smaller than the median, it went too far on the max on the bigger end, just wrapped around to the smaller size. Okay. But again, if you use like the newer compiler versions, it's irrelevant. You don't have to worry about it. But it's still something that it's good to know, right? It's good to know in general in computer science, in programming. There's this thing called overflow and underflow. Okay. And second, who's heard of any? So that was all about that was all regarding overflow underflow. And by the way, if you have any questions, feel free to stop me. Otherwise, I'll just keep going. Okay. So who here knows what an oracle is? And no, it's not the lady from Matrix. Yeah.
Well, it basically like integrates other third-party data into your smart contract.
Yeah. So let's say in the Matrix, what does the oracle do? It tells the truth or whatever, right? It foresees something. Okay, so it gives you data that you otherwise won't have, right? So an oracle in the blockchain, you can think of it as a trusted. Sorry, let me move Zoom. It's a trusted data source, all right, and it's usually used to fetch data that you cannot natively get in Solidity. Things such as price, right? So what is the price of, let's say, ETH against AVAX, right? The price, you can't just get it from within Solidity. You gotta ask, let's say it could be a Uniswap pool, the ETH and AVAX pool, or you can ask Chainlink for their price oracles, right? Another example is any API basically means like an endpoint. So let's say, so when you're visiting any website, the web page displayed to you is returned by an API, right? It's just that the browser parses the information and displays it to you visually as a web page. Okay, so an API is basically any web URL that returns something, right? So there's also off-chain API oracles, mainly done by Chainlink, right? So you can use it to access off-chain information from your smart contract. So let's say we're betting 1 ETH on the lowest temperature tomorrow or the weather tomorrow. You know, it's a weird bet, but right. But you can bet that, right? And how are we going to verify said information? How are we going to verify what the weather really is? Right? So you verify it by using a trusted off-chain API oracle, right? Because you can't just have someone telling the contract what it is. I mean, that's technically what an oracle is doing, but an oracle is when it's trusted, you assume, and all of its users assume that it is neutral, right? So you can't bribe it so that it feeds you some information that you want. It's always neutral. Okay, so that's like the general concept of oracles, right? But now we're talking about oracle manipulation, right? And this is and there are two ways in general to manipulate an oracle, and it's very bad. Why is it bad? Because when we're using oracles, we're assuming it is to be trusted, right? And now the oracle is abusing your trust and giving you false information, and you won't know because you trust it, right? So there are two ways to manipulate it. The first one is the easiest. Well, not the easiest in terms of technical difficulty. So the oracle operator can just feed you garbage data instead of actual data, right? So this would be you misplaced your trust, which has happened, I'm sure, numerous times throughout everyone's lives. And the other manipulation is actually people can actually through various mechanisms, they can actually manipulate the oracle. So they are able to manipulate where the oracle get their data from, and then in turn, the data provided by the oracle will be manipulated, right? Not necessarily false, okay? Because the oracle is still truthfully reporting what it knows. It's just that the source of that data is manipulated, so the oracle doesn't know either, right? So we won't talk. Well, obviously, we won't talk about the first one because just buy someone out or something. And obviously, it's not that easy with a decentralized one. But let's talk about the second one. Okay, how to manipulate a price oracle? Let's say. Okay, so let's suppose we're building a DeFi project, which none of us have ever done. I've never done it. But let's say we're building it that uses a spot price data from Uniswap pools. So spot price basically means the price at this moment. And pools with low liquidity, meaning that there's not a lot of volume. And when there's a low trading volume, it means that there are fewer people asking to buy and sell. And when there are fewer people asking to buy and sell, it means if you, let's say only, there are only 10 people asking to sell at like $20 and that's it. Well, if you put in an order of like $2,000, it just eats through all the sell orders and and then there are no sell orders anymore. So your price can just keep going up. It just keeps going up because as long as there's no sell pressure, you can now define, how much you're willing to kind of pay. And that's like the gist of having like a low liquidity. And that's usually, so low liquidity pools usually come with very high price movement. So you gotta be careful. So this is not financial advice, but when you're trading things, you gotta also watch out for volume instead of just looking at price pops. Okay. So pools with low liquidity can be attacked by something called flash loans. Okay. So a flash loan is basically, so this is quite interesting. Now in DeFi, usually the most common DeFi loans that everyone can make use of, and people do make use of it, is basically something called collateralized loans. So basically you deposit a certain amount of collateral and then you're able to borrow a certain percentage of your collateral from the protocol. And then you also have like a liquidation, is it debt to value or something? I forgot. But you're able to borrow a certain percentage of it, but then because the price is floating, so you have like a liquidation limit. And once the so basically if your collateral decreases in value and the asset if it decreases in value faster than the asset that you're borrowing, then you will soon go over a certain percentage, basically borrowed, percentage borrowed divided by your deposit collateral. And when that percentage becomes too high, you basically get forcefully liquidated. So basically all the collateral is being sold automatically by the protocol to repay your debts. And also they charge like a 10% fee or something. But hey, you don't need to borrow with a credit. You don't need a credit score to borrow. And the interest rate is floating. So if there's not a lot of demand and a lot of people looking for others to lend their money, then the interest rate could be as low as 1%, 0.something%. Okay. For DeFi pools like SushiSwap, they prevent like a floating, like a dynamic interest rate, where it increases and decreases based on the borrowing demand. Okay. So that's like the more mainstream way of borrowing things. That's how normal people borrow. But there's also the concept of flash loans. So flash loan basically, so you remember how we said in collateralized loans you have to deposit collateral first. But in flash loans, you don't have to provide any collateral. Why? Because you're required to repay the entire amount within the same transaction. So and again, what is one of the very crucial characteristics of blockchain transactions? They are atomic, meaning that either the entire thing happens or nothing happens. So when borrowing and repaying happens within the same transaction, there's basically no risk for the lender because the borrowing either happens and you're able to repay it, or if you can't repay it, then the borrowing doesn't happen either, right? Yeah.
I don't understand borrowing and repaying in the same transaction. What's the point of that?
Oh yeah, so I'll get to it. So it's used for arbitrage, and I'll show you how, right? But the gist is you borrow and repay massive amounts, like you can do millions of dollars within a single transaction. No collateral, you just have to pay like a 0.7% fee. All right. So if you're trying to arbitrage something and the profits, if the profits can basically outweigh the 0.something fee, then you're actually able to just get money out of thin air. Like you're able to arbitrage without having any of your own capital, basically, which is crazy. right? So here's how flash loan here's how we use it to attack a certain pool or something, right? So the attacker can first, they take out a flash loan on AVAX on some pool with a larger liquidity, meaning that when they take out that loan, there's going to be a very minimal price impact because the pool is very large, right? So it's like when you're it's like you dumping a bucket of water into your toilet versus into the ocean, right? There's like when you dump a bucket of water into the ocean, nothing happens because the ocean is so huge. But if you dump it into your toilet, you see like a noticeable difference in the water level, right? So you pick out a flash loan on AVAX. So you take out a bunch of AVAX on some other pool, right? And then so that has that basically produces a minimal price impact on the other pool, right? And then you use AVAX to swap for Ethereum on our tiny DeFi pool, right? So what happens is that this would basically, when we use AVAX to swap for ETH, we're basically taking ETH and then dumping AVAX into our liquidity pool. And what happens when we have a tiny pool and we dump a bunch of AVAX into it, right? So the supply just massively increased. And what happens when supply is massively increased? The price dumps, right? Because there's so much more supply. And that would crash the price, right? And then we're now able to buy AVAX in our pool for pennies at a much lower price, okay? And then we're able to sell that AVAX on some other pool for market price because this price impact is local, only in our pool. And the best thing is, or the worst thing is, because everything's within one transaction, no one has any time to react, all right? And then you repay the flash loan and then pocket the profits. And actually, a protocol on, I'm not sure if it's the mainnet or Binance Smart Chain. I think Binance Smart Chain because there are a lot of questionable things on Binance Smart Chain. But there's something called CreamFi or something. It's a very sketch name. So I think they got attacked this way 3 times. I think first and second time they got attacked. I think 17 and 20 something millions of dollars got drained. Third time it was 137 millions of dollars. So this kind of tax really works on smaller pools. And if you don't write code and build in have built-in price stops or whatever I actually don't know how to guard against flash loans. Haven't looked into it because I'm not a DeFi person, but just know that these attacks are very real. And if executed well, the attacker doesn't have to, they literally just rob your money because they don't even need to have any capital to begin with, right? And so due to the nature of it, everything's done within the same transaction. There's no time for you to react because by
Hey, Jack,
it's already over. Yeah.
how do you load all of those actions into a single transaction?
Well, you have to write your own custom smart contract to do it.
Mm,
Do you need a smart contract to do it, or can you do it in JavaScript, just a script, and then just run it interacting with all these?
Well, the thing is, in JavaScript, you're always calling smart contract functions. And every single function call is one transaction. But you want everything to happen within the same transaction, so it's gotta be instability. It's gotta be within one function call. So you're calling the flash loan contract, you're calling DeFi contract, you're calling the pool that you want to exploit. So you have to have some smart contract knowledge to do all this.
Yeah, so are they deploying a smart contract and then calling the functions in the smart contract
Yeah.
to do everything?
Yeah.
So it's not just happening upon deployment.
No. Well, you can also do that because you only need to do it once anyways.
So are there examples of smart contracts that actually do all this stuff that are public? Or
There are, but you gotta be
incredibly smart to understand what's going on?
yeah, because what happens is, so let's see. I've heard of people making a lot of money ethically with flash.
Well, yeah.
For charity.
Yes,
I think you have to work really closely with the miners too, right? To make sure all your transactions go within the same
so
block.
it's a single transaction. It's one.
Well, is it always one? I mean, because it has to happen within the same block, but you can have multiple transactions per block,
You could, yeah,
right?
that's fine too.
So you could
Yeah, you have
take
to-
out a flash loan, do an arbitrage,
Yeah.
swap, and then back.
Yeah, it
But to
depends on,
guarantee that all of those are
it
in the
depends on
block.
how much you do, because because you can, if you do too much, you can blow the gas limit in a single transaction. But yes, but if you were to do that, then you have to work with the miner. But also because arbitrage opportunities sometimes are they have a very short window. So then, it's not that easy, but then also it's easy in the sense where you don't need any capital to do this. Yeah, as long as it's profitable enough, if the thing that the amount of money you're getting can massively overweigh the flash loan fees, then you can just.
Is there a certain threshold of how big a liquidity pool would have to be in order to protect against this? Like how would a flash loan attacker?
I honestly just think it really depends on how much they're taking out with the flash loan versus the total amount of assets or whatever in your liquidity pool. And there are also, I'm sure there are ways to guard against it. I'm just not very informed. I'm not informed enough. And we're not at a point where we can write DeFi contracts anyways. Yeah, but there are contracts out there that claim to do arbitrage using flash loans, but some of them are actually malicious and they actually drain your wallet instead. So.
I also heard a story about, I remember there was this guy who like sold his, it was either like a board or the crypto fund, it was for $5 million, it was like for $5 million and went crazy on like exchange splitting and everything. It was really just a flash loan. He was able to borrow the money, sell it to himself. And
Yeah, wash trading,
Yeah.
right? Yeah, that's just to pump up the price. Yeah, that's a good idea. Why don't I do this? Well, then he has to make sure that the NFT actually sells for more than that. Otherwise, he's left holding the bag of his flash loan fees.
Yeah.
Yeah. Yeah, but and again, wash trading is totally legal. Well, it's not regulated, it's not illegal. But yeah, I'm sure there are like tons of wash trading on the NFTs because how do you know if two accounts are related, right? You can just pump up the price artificially, right? So that was all about flash loans, the dangers of DeFi, running your own DeFi pool, you gotta be careful, right? So again, imagine if someone, so we were talking about damage done to the DeFi pool directly, but now we're talking about collateral damage, right? So let's say we are pulling data from that price pool. Well, if that pool gets attacked, then the price wouldn't be correct anymore, and then we're taking that price, so we would get screwed too, right? So yeah, so this can open doors to exploits not in our pool, but in the price, right? So basically we're getting faulty data now. And then that might cause us to lose money. Let's say we're doing our own custom swap, but we get our price from that pool. And then if that price is affected, it can negatively affect our swap, right? And the way to mitigate it is actually pretty simple, right? The way to do it is just to aggregate data from multiple oracles, right? So instead of having a single source of truth, have multiple sources of truth, right? So just pull data from multiple liquidity pools or whatever to check that. And then, you either, you don't average the price, but you check for anomalies, right? And then there's another way to fight this oracle manipulation is use something called time-weighted average price. Right, so instead of taking the spot price, you take a price that's weighed in a certain way, and it's averaged over a certain time frame, so that it's harder for people to just screw with your price that way, because you're now taking a time weighted average, right? And actually, aggregating data from multiple sources, I believe Chainlink already does that for you, but then now you're trusting Chainlink instead. Okay, any questions on oracle manipulation? This is fun, right? I mean, you don't have to. I mean, one of the fun things about this lecture is that you don't have to incorporate any of this into your homework assignments. So you don't have to. So it's not more coding for you. But I think these are good to know, right? In general, and then when you're writing smart contracts in the future, if you ever do write DeFi stuff, right? First, whitelist me, but secondly, look back at this lecture, right? So next, let's talk about front running. All right, so this has something to do with miners. Okay, so the fact is that everything on the blockchain is public, right? Now, this includes the mempool. If you guys remember from 256, mempool is basically the place that pending transactions go to, right? So these are transactions that are broadcasted to the network, but yet to be picked up by a miner because of capacity issues or whatever, right? So this is a mempool where pending transactions live, right? So thus, your transaction is public the moment you broadcast it, right? Even if it's pending, it's still public, others can see it, right? So front running is an attack where basically the attacker is trying to screw you specifically, right? So they see your pending transaction, and then what they do is they submit an identical transaction, let's say buying an NFT. But in this case, they're buying it instead of you buying it, and then they raise the gas fees, the gas price, so that theirs goes through first, and then you get screwed. So that's the front running attack, and that actually happens all the time in I believe actually DeFi and NFT space. There are actually services out there that you can actually watch a certain address and just front run everything that address does. Yeah, it's interesting. And usually front runners actually they also sometimes they work with the miners to make sure that their transactions are always whitelisted and have like the highest priority, all right? And this is like an example. Let's say you're trying to ape into some NFT, right? Because we're all DGEMs, right? So you send your transaction, so in this case, let's say we're able to mint very specific NFTs, right? Let's say you're eyeing a specific NFT, you want to mint it as soon as the minting opens up or whatever, right? But you successfully submit it on MetaMask because, well, and then you think, well, then I'm good, I got this because what MetaMask does is it does a dry run or a static call of the function to see if any reversal happened, right? And if the revert happens when it's doing the dry run, then it stops you from submitting it. But if MetaMask allows you to submit a transaction, it usually means that your transaction is fine, it will go through. That's what it usually means. But you submit it, but then it fails later, and you see that someone else has it, right? So basically, the attacker saw a transaction, and then decided to screw you, and they basically saw a transaction in mempool, and then they minted the same NFT, but then they gave it a super high gas price, and now that one is prioritized, and by the time the miner gets to your transaction, the NFT is already gone. Okay, so you just got robbed blind by a front running attack. All right, and this is like difficult to fight against. Actually, it's very difficult to mitigate unless, I mean, like when someone's onto you like this, the only hope is to also just keep raising your gas prices, I guess. But then it would also cost you a lot of money because now you're paying something preposterous for gas. So that's just front running. Right. It's also okay. So now we're getting to timestamp manipulation. Okay. So one of the ways that we and also this is what we're going to do in homework 6. So in homework 6, so we said every auction has a deadline. Right. So that deadline will be a timestamp. And let me show you an example of a timestamp. Right? Okay. This is called a epic converter, right? So this is the current Unix. Is it called epic? Is that how you pronounce that word?
Yeah.
Epoch. Okay.
That's what I thought.
I don't. Epoch time. Okay. Unix epoch time. All right. So that's basically the time passed since I believe January 1st, 1970. Okay. And this is the number of seconds passed. And this is basically what you will get when you call block.timestamp. Okay. And that the block.timestamp basically returns to you the number of seconds
Zoom folks, the system just shut down again. Very nice. Give it a few minutes or 1 minute actually.
Okay, can everyone hear me okay on Zoom? I guess. Yes, I'll take that as a yes, because I see myself. Okay. Okay, so when you call block that timestamp, basically what you get is the time at the time of the blocks mining, but in this format, second since 1970 or whatever. Okay, so that's basically what the timestamp is, right? So for homework 6 for the deadline, what we're doing is we just basically want to compare it to current time, which is block that timestamp against the deadline to see if it's already past the deadline. But notice that, but note that block that timestamp isn't the current time. It's the time of when the block is mined. And which block is that? It's the block that the transaction is contained in or whatever. Okay, so that's not really the current time, but it's like a close estimate, I guess. Okay, but a block's timestamp is actually determined by the miner of the block, meaning that a miner can screw with the timestamp. I mean, obviously it can't go backwards, but it can go into the future. Okay, and again, not that you shouldn't use it because there are so many miners out there today that it's hard, and then because there's so many mining pools, it's hard for some miner to screw you specifically. But it's just something to keep in mind when you write code that relies on block the timestamp. Okay, just something for you to keep in mind. Okay.
Jack,
So
can I ask you a question?
Yeah.
If they screwed with the timestamp, wouldn't like other miners recognize that chain is invalid, and then eventually you just put your contract back out again, and then it'd be fine?
Well, you see, the thing is, messing with the timestamp doesn't break the rules, unless you go backwards, I guess. But if they make it go into the future by like a minute or two or something, then like if it's still within, I'm actually not sure what's like the range of timestamp that's like, that the miner can mess with, but as long as but messing with the timestamp doesn't necessarily break the rules of the system. So it's not that, so it doesn't make a block invalid just because the time is different, because it's true that different people come up with blocks at different times, right? So that's just the time at which a block has been mined, more or less.
Okay, makes sense.
Yeah. Okay, let's move on to this one. This one's more interesting, okay? Something called denial of service, and there are two types. We're talking about the first one. It's called a revert attack, okay? So let's say we're building basically homework 6, actually not homework 6, something like homework 6, a bidding platform, right? Each bid must be higher than the current bid. A new bid basically locks in the new bidder's funds, and then the locked funds of the previous bidder is directly transferred back. So instead of holding a balance in the smart contract, we directly send the money back to the previous bidder, okay, using dot transfer. Okay, and this is not a problem if the previous bidder is a normal account, a human operated account, so an EOA, externally owned account. But if the previous bidder is a smart contract, then we could have some issues. Okay. So if you guys remember what transfer does, transfer, we use transfer, I think it was homework 4, I forgot, to send money around, right? Send money to certain accounts, okay? So what transfer does is that it triggers the receiving contract's fallback function or receive function to react to incoming funds. So before, I forgot which version was it, is it 0.8.0 or 0.7.0? There was something called a fallback function. Basically, when you call a smart contract and the function that you're calling doesn't match with any of the existing function signatures, it automatically goes to the fallback function. And usually what the fallback function does is that if there is data sent along with the call, which means it's not a fund transfer, it's like a call, it just reverts it. Because you're basically telling the caller you call the wrong function. But if the data is empty, and there's value attached to it, it means you're trying to send money over, so it accepts the money. Okay, but I forgot since which version, it basically got split into 2. So there's still the fallback, right? But there's also the dedicated receive function. And the receive function is specifically used to handle incoming funds. And we never wrote this because by default, receive just receives the money silently, and fallback just reverts the calls, the incorrect calls. And so that's the default behavior, right? If we don't specify it, that's how it works by default. But we can modify it to game the system, right? So one of the things that transfer does is that it reverts the transaction if the receiving contract reverts when it's accepting the money. Okay, now this is usually used as a safety mechanism because that's one way to prevent a failed transfer. But the problem is the attacker can purposely revert any incoming funds so that any attempt to transfer will revert, all right? Thus, the attacker will forever be the winning bidder because what happens is if a new person tries to bid higher, it locks their funds in, but then within the same transaction, when you're trying to refund the previous bidder, which is the attacker, the dot transfer fails because maybe in the receiving function, it just reverts. And now basically the new bidder cannot be the new bidder because that bidding transaction never goes through because the transfer used to refund the previous bidder will revert. And now the attacker will be forever stuck as the highest bidder and will eventually win the entire auction. And no one can outbid him because no one can successfully, refund the attacker because the attacker just reverts everything, right? Does everyone see how this works? Any questions? Let me know. Right, no questions. Okay. So let's move on to the second, denial of service. Right, so the reason why it's called denial of service is because notice how no one else can bid anymore. So that's denying everyone else of this service, right? So this one's using revert. Now this one's using gas limit, right? So what this is doing is, again, the same platform, right? And basically what happens is an attacker can first submit a legitimate bid. And then afterwards, this is not even that one. So this is like a different system where the refund happens at the very end, right? So the refund happens when the auction is settled, and then it refunds all the non-winning bidders at once. So basically it stores all the bidders in an array or map or an array, and it uses the mapping to keep track of how much each person should be refunded or something, okay? But what an attacker can do is it can submit a bunch of garbage bids from a ton of addresses, right? Just to increase the number of non-winning bidders, right? And at the end, when you're trying to settle the winner and then refund everyone in a single transaction, you have to iterate over a huge array, right? Because the attacker submitted a bunch of bids, right? And then when you're iterating over a huge array, eventually, if the array is big enough, you can blow the gas limit. And then basically the settlement can never happen. So the winner can never win. The funds are forever stuck. And basically no one can get any of their money back or anything because whenever you try to settle, because there are too many bidders, when you're trying to go over the array and refund everyone, it's just gonna go over the gas limit and the network wouldn't allow it. Okay. So this is another way to, yeah.
How does the attacker benefit from that?
Oh, it just screws with other people. And if the attacker's early enough, they can submit like tiny bits, like 0.001 or something. You know, if there's no increment setting in, if if the floor price is low enough, then it's able to screw with things. But you know, this is one of the things where it doesn't necessarily benefit the attackers, but it just causes frustration for others. Right? So if you're rich enough and you want to screw with people, this is one way to do it. See, yeah, it doesn't benefit yourself, right? It's like trolling online, you know? I mean, why would you sit in front of a computer and then just write garbage comments and trigger other people all day, wasting your own time? It's not productive, but hey, it's screwed with other people's time, right? So that was so this is attacking this bidding system by blowing the gas limit on purpose. And this is also why you should never have arrays that grow indefinitely. And you should always be careful when iterating through the entire storage array, because storage arrays can grow indefinitely and you won't know how long it is. And you know, if you just try to iterate through it in one go, then it might just go over the gas limit and you can never basically do what you're trying to do. Okay. Okay, the next one is called block stuffing. This is interesting. It's the same bidding platform, and let's say you know the auction has a deadline. So what the attacker can do is the attacker can submit a legitimate bid, and then he would spam a bunch of random transactions with a crazy high gas price, so that nobody else, so no other bidders' transactions can be included in the block. So he would just spam transactions that basically consume a ton of gas, and also the attacker gives them a super high gas price, so that the miners will prioritize these garbage transactions. So the attacker can keep doing this until the auction is past the deadline, and then now no one else said all the previous bids would be invalid because now the auction is past the deadline, and then the attacker would be the sole bidder because they kept spamming garbage transactions so that no one else's transactions could be processed, right? So this is like another way. So this attack actually got carried out. There was this game, I think it's not gambling game, but some game on Ethereum where whoever is the last to call the function before the deadline would be the winner. And the attacker just spammed transactions like this to make sure that no one else can call after he did, or they did. And then, so up until the deadline, so the attacker would be like the last person to call the function, and the attacker just won the game that way, right? So that was block stuffing. So three different ways to deny other people of service. Okay, so how do we mitigate this? Okay, so for the revert thing, we use something called a pool payment system. This is actually what we did for, I believe, wait, is this what we did? I think we did it at least in one homework assignment, where basically the refunds we internally track the refunds, and then we ask the users to pull their refunds or withdraw money separately. Okay, so this would basically prevent the attacker from reverting any transfers externally. Okay, so basically separating the money sending and the account keeping. Okay. And the second thing, how to prevent a gas limit thing, is again, we use a pool payment system, because the problem was, again, we're trying to go over a huge array of people of addresses we're trying to send out money. So instead, just keep track of them and then ask each address to come get your own money back. Okay. And also just be careful of iterating over arrays with like unlimited size or an unknown size, because you don't know how large it could be. Okay. And block stuffing, really the only way to do it is just to pay up and just keep raising gas prices until yours gets through. And this is also why the gas price always skyrockets whenever there's like some kind of airdrop happening on Ethereum. I think in May or June, I forgot when, there was like a DYDX airdrop or something. and then gas price just spiked because everyone was trying to be the first to get it, and then first to sell or first to do whatever. So people were, and then especially when people let's say, well, this can also apply to ICO auctions, or not auction, but initial coin offerings or whatever. When there's a set amount of coins being sold, and you really want to get in, and let's say you're trying to buy 100 ETH of ETH token or something, I don't know. And when you're spending 100 ETH to buy tokens, why would you care if you spend $1,000 on transaction fees or whatever, right? You can totally do that, and that basically just screws with everyone else. When ETH tokens, I don't know, soon. Okay. Not financial advice. Okay, so this is more interesting. It also has an interesting name. It's called force feeding. It's the actual name. So this is very useful. So this is very relevant for contracts that directly utilize address balance. Okay. So recall our contract from Homeworld 4. Okay. So if we modify it so that any incoming fund is immediately split among the recipients instead of the whole payment system we talked about. Okay, and let's also assume that the incoming fund is read from address.balance instead of message.value for some reason. Okay, this would present an issue. Okay, so because if any Ethereum are sent before the splitter is called, then address this.balance doesn't start from 0. Okay, and then when you're splitting the money, and if you're using this balance, then the actual amount split would actually be more than when you deposit it into it. Not that it's a bad thing, but it would just be wrong, right? But recall how every smart contract has a default fallback and receive function. Well, you can say, well, we can just revert on these so that we disallow anyone from sending us money, right? If they send us money, we'll call the receive function, we'll revert it so that we make sure address this.balance always starts from 0. Okay. Well, yeah, well, can't we just revert it, right? Well, we could, but there's actually one thing that bypasses receive and the fallback to force feed money into a contract. And that is something called a self-destruct. So you can actually code into the contract a self-destruct function. And that function takes in a single argument, which is the address of another contract or another anything, right? It's just another address. So what self-destruct does is that it deletes itself, the contract it's contained in, and it sends all the remaining ETH into the address specified in the self-destruct. And that is actually force fed. So the money sent through self-destruct does not trigger fallback or receive. Right, so that's why it's called force feeding. So you're forcing ETH into a contract, bypassing all the controls. Okay. So the way to mitigate it is just to not use that, to keep track of things. Just keep track of it separately. Read from message.value, save it elsewhere, and then just avoid using this in general. Okay. This is only useful if you want to read from like some. I don't even know. I mean, it's there, but I don't know. Just avoid using it. Always keep track if you can. Okay. Now the last one is more interesting. The last one is called reinteresting. This is like the more famous exploits available, right? So recall how the fallback or receive function, we use it to handle incoming funds, right? And when an external function is called, right? So let's say we do, so even .transfer, you're saying, well, I'm calling it on the address object or whatever, but you're actually handing over control to an external function, right? So whenever you call an outside function or you do fund transfer, you have to be very careful, because now the execution is not in your hands anymore. You're handing over execution to an external entity, and you don't know what that external entity has coded or anything, right? So the control is now handed over to the callee, right? And these functions can actually be doctored to exploit the caller. So let's see how that works, right? Right, for example, let's take a look at this. It's very simple, right? A code snippet. So we keep track of user balances with a mapping. And in this withdrawal function, what we do is first we determine how much to withdraw from this user, right? What's their current balance? And then, so message.sender.call.value is basically how we send, this is like another way, an alternative to .transfer. We can use it to call external functions, or we can use it to send funds. All right, and it returns two things. It returns a Boolean indicating if it reverted or not. So if the external caller reverts, in this case, this will not revert. This will return a false for the Boolean, and this is why we check for it. But you see that the problem is, and at the very end we clear out the user's balance. But if you just look at this directly, you don't really see a problem, because why? Because everything's atomic. Why does it matter if I clear out the user's balance later? I determine how much they should get. We transfer it to the user, and then we clear the user's balance. It's very logical. Nothing's really wrong. But remember how whenever a contract receives funds, the receive function is called implicitly. Well, what if that receive function calls this one again? Right? So the problem will become basically let's go over this. So let's say the user has 1 ETH here, okay? So the amount to withdraw will be 1 ETH. And then we transfer 1 ETH over to the external user. At this point, we haven't cleared out this yet. Let's see, and then this will trigger the receive function on the receiving end, right? Let's say the receive function calls this again. And remember, we haven't cleared out this yet. So when it calls this again, when the receive function calls this again, it will go over this, and then this will still be 1 ETH. And then it will call the receive function again. Receive calls this again. It just keeps draining money out of your contract until it's empty, right? And then you do accounting, okay, equals 0 later. When everything's now like drained, completely drained, you say, okay, the user's balance is now 0. Okay. And the external receive, it can internally keep track. You can actually code in how many times do I want to keep calling this, right? So that's a problem, right? And the mitigation is actually very simple. You just do accounting. You can just do accounting before you send things, right? So imagine if you just flipped, you just move this line before this line, the entire thing would be prevented, right? Because if you set the balance to 0 before you call the external function, if it calls here, if it comes back to call again, the amount to withdraw will be 0 because you cleared it before you call the external function, right? So that's literally how simple it is to avoid reentrancy. But you'd be surprised how many exploits have been done this way. Okay. So, and then another way is actually to use send or transfer instead of call, right? So the reason why is that send, so the difference between send and transfer is that if the transfer fails, transfer will revert, but send will just return true or false. Okay, so that's the only difference. One way is, again, to use send or transfer instead of call, but it's not recommended because, and the reason why it works is because send and transfer, they hard code, they're hard coded to only give the external caller 2,300 units of gas. And that is only barely enough to call the receive function and at most emit some event or do some very basic thing, right? You can't, and basically you can't have these call cycles because the amount of gas forwarded is very minimal, right? So it'll run out of gas if it tries to do the reentrancy. But the problem is the gas forwarded for send and transfer, they're hard coded, meaning that when gas costs change in the future, it might break send and transfer because 2,300 is hard coded. All right. And the reason why call can be messed with is because when you use call, all the gas from the caller is forwarded to the external function. So let's say you're an attacker. So you can basically just, when you're calling a function, you can give it a super high gas limit, right? And then you would have like a lot of gas to work with, so you can call it a bunch of times, right? But if you only have 2,300, then you'll run out of gas before it can do anything, right? But again, if the network adjusts gas costs in the future, then 2,300 might break, right? So that's the reason why. So the solution really is to use call with a reentrancy guard. So basically it opens up and provides something that basically checks if the external caller is trying to call this function recursively or in cycles. And also just adopt the previous advice where you first do the accounting and then you call external contracts, right? All right, so any questions on any of the things that we talked about today? So these are like, I'm not going to test it, well, I probably will, but you don't have to, like, I'm not going to give you exercises specifically for these. But I will be looking at your code to check for, when you do fund transfers, do you do accounting first? Or, when you're, what else? Well, I mean, all of these, they don't really apply to us. So I guess, also, if you're trying to iterate over like a huge array or something, right? So I'll just be checking for these, but I won't say like write a contract that uses reentrancy to exploit another contract. I'm not going to do that. Or maybe that would be a fun actually try that.
What are we supposed to use instead of address this balance again?
Just keep track of it separately. Use your own mapping. Whenever you receive funds, you get the value from message.value and then keep track of it separately. All right. Any questions on what we talked about today? So this is more informational, but they're all very good to know. Okay. So there will be more attack vectors in the future, but these are the ones that are well known. Right. If we don't have any questions, what I'm going to do is like if you have any homework 5 questions, I'll be here to answer them. And that's about it. You have like 40 minutes to just work on homework 5 to 6. And actually, in the coming weeks, I'm going to have more in class time just for you guys to work on stuff that you can ask questions and whatnot.
That's initially what after I was trying to do some stuff, I think worked.
Yeah.
I did suppose, man, yeah, just didn't work anymore. I got pushed to GitHub,
No, it failed because it tells you the 2 errors. So 104 is 23 value, line 104 in 23.
Yep, when it came the arguments,
But that's not. Oh, and also, okay. Okay, so this is your problem. You declare title here. So there's a title here.
Oh,
So which one? So it doesn't know which one you're. So you guys. Yeah. So that's what no shadow means. So this basically means you're you're shadowing the previous declaration. Yeah.
This is reverting.
Yeah.
like an await, it's not a void and then we'll wait here. So this is 190.
You can just add.
100. Try like that.
This is just having like a donation.
Yeah, because the arguments for the major campaign is the ID and donation, the funds raised. And I'm just doing donate. I don't know if that's actually gonna fix it or not.
Let me close this and just. Oh, that's right. That's all right. There's a 1.5. Yeah, it's- Okay, so a lot of these are just formatting stuff, right? So you can just do.
So it's
you can
going
turn
to
on
like this
format
one
save,
works,
switch
right?
format.
So it's going here, and that's going. When it does this line,
Format the
right
right
here.
here.
It's doing dot edge. Oh, add is here. Um, Actually, yeah.
Hey, thank you, Jack. I'm gonna post some questions on Piazza.
Yeah,
So it's like doing this and then saying that. I did this by just giving it like the constant transaction avoidance back to the part.
Okay, so you just
So
have
I did like,
this.
I did like the weight, the weight expect. Just do like.
So maybe without any of this.
Yeah, how else can I ask it? Sorry. I can't pull it over, but.
So can I get a error on that?
I didn't switch it up. Yeah, I don't know why. It just-
Just working on 45 expense.
Also, this is in long.
Probably leaving it on, that's supposed to be as, that's supposed to be a testing.
And the error keeps saying it's not human.
Oh, for describe cannot do it.
So those all the things on the hits not described, so okay.
It's only it's.
So this, when you're making this thing, and are the cases, are you actually making it properly?
And also, give me 1 second. Okay, so everyone, folks, if I can have your attention. I totally forgot about this, but. Let's install, so go to your VS Code, open up extensions. Install 2 more plugins for me. Install ESLint and Prettier. And Prettier.
I really don't like ESLint.
Hmm?
I don't like ESLint.
Well, the reason why is because it can show your errors in real time instead of like every time you have to look at the git log. Because what happens, because with the template I'm providing, because we're using TypeScript, you have to resolve all the errors before you can commit.
I know, but I always, that's what I don't like about it.
Disable TS completely. Yes, yeah. Okay. So install ESLint and Prettier. And after,
Yes, Link.
yes. And after you do, do Command Shift P. And then type in format document. And when you click, and when you type format document, when you click on it, I'm not going to click into it, but when you click into it, it's going to ask you to configure the default formatter, and then just choose Prettier. And also don't forget to in your preferences settings, don't forget to turn on format on save. Okay, so that's going to save you a lot of headaches in terms of. So basically, what it does is instead of having to look at the Git output to see what's wrong in your code, it basically underlines it in red directly in your editor. So ESLint and Prettier, 2 plugins.
Command Shift what?
P.
Command Shift P.
And then type in like.
Format documents.
I like to. It's like the functions.
Did you modify
Problem
something?
is when it goes into get campaign. Or when it goes into add code in it,
It's just auto and it gets like that's what it's.
The one for the, one reverting, right, you do it here, it's just getting
Yeah. There's like a problem with. That's like a massive scale.
Or can you just put the other line in front of them? I'm trying to pull some stuff.
Oh, wait, is it? Did you save this file, by the way? No, okay.
I feel like this was, it's a typical, just not like transfer. Like, yeah, I don't. Maybe before. Should I try this? I don't know, I think there's. It's only. I'm not sure where the. It's like for both of our tests. It's right. Whatever you call it. I'm doing the. Same thing. What is the exact same thing?
Maybe you're like creating, you're saving a campaign and then you're also saving, using that campaign and saving it for another transaction.
Saving use there. I see you can also just. I mean, I'm thinking also, if you're trying to do something similar in the format you expect, the way you have your tests, right? You have on this line here, you have the expect, you run the intent. Why don't you just change everything together in your transaction down here? Is your all the transaction constantly wait for us our next campaign and that one there is I think just what it is, right? Yeah.
Oh, yeah.
And then so why don't you just do like expect inside your parentheses and we'll wait on start. So do the same format. Yeah. If this is cause if your ways expect to make contract. What I'm trying to get at here is if you think that this line is running, it's not getting to this next line here, you just chain it. It's gonna have to.
Yeah, I feel like, can you do the Jordan first?
Through the hospital.
Ask Jordan first.
Hello. I tried
When you use
to
chain
find
to units,
and
everything
I
after
tried to
the
Yes, do
and I
what
tried to
expect.
solve it
Yeah.
up the haircuts and everything. And it just
Okay.
Let's do here.
Isn't it really late for the next start?
Yep, there's wait first. I guess you're right. Yeah, I guess you're right. Yeah, that was my bad. I got that wrong. Burn, I don't know if that's gonna fix your problem.
Same exact code is up here, so.
You're expecting to be different.
and it sounds basic, so all of it.
It's gotta be like the end campaign owner, not the owner.
Yeah.
It's not the cat cap 256.
No, that's the.
Ask one, and then one of them ask one.
I would say probably do fast check this one. I haven't written this contract. Yeah, sorry about that. That one. Yeah. that I showed you, but
Yeah.
so basically,
Confusing yarn.
right,
We can't figure it out until.
so I'm gonna guess that,
Oh, I do have one question on the functional.
classroom,
Like reverse. I didn't do anything after. Just everything after.
Did you have a question?
Yeah.
So while I'm waiting for some of these solutions, I can say,
yeah, that,
Campaign.
that'll work to some extent, that just
First one I have is basically just checking for the correct campaign owner and remember.
Yeah.
And then the second one, I keep getting this error, not campaign owner. So for whatever reason on this line.
oh, because, well, did you start the campaign?
that was.
And so like you would start the campaign first. In the test
Yeah, so the problem is you got the ID, sure, but you can't end something.
that hasn't been started.
Yes.
Oh, I
Yeah.
see.
And the reason why it's telling you you're not the campaign owner is because the address is 0.
Yeah,
Owner is 0 because it's just initialized. It hasn't been initialized.
oh, I see. Okay, all right.
That was it, yeah.
Something I gotta do is so simple, but like.
256.
Yeah, let me see, I forgot what they're.
Yeah, they basically just said use block height as a deadline.
Yeah.
So does that mean we should pass it, or like when we start adding here before, like whoever's running the program will pass
So
the
what you could
deadline
do
as
is
well?
add it
Yeah.
before and then
And
change
then we
this
just
to
compare
after,
that to the block.
so then it doesn't work. You know what I'm saying?
Still do,
Like add,
previous
like
one.
add the start, do one in the front,
the previous one, like,
Yeah.
the one that goes up to 8.
scroll up to the
Yeah.
start.
You know what you're gonna be getting.
Now it
Yeah.
should work.
Do you have anywhere that you started?
Yeah, now it works. Now it just run trouble as well. I don't know why this.
So
Like in
like,
the
do I call it
functional
MPX?
test that you started
I
with?
think yeah, it's
Test, trouble test,
trustful, what are you trying to do?
test it, like I think I did everything.
Test what? Truffle is only, we only use truffle to deploy. Testing is built in. You don't have to. do
Wait, scroll up.
Testing is just npm run test.
You started, so you
Oh,
gotta
you
use
don't
like.
worry about it.
I mean,
Oh,
you
these
can
are
just
for
use that,
deployment.
still can't start, you can wait like that.
Like faster,
You know,
Yes.
how like,
it's
What's
used
it
for
called?
a lot of things, but I found there's just some
Yeah.
things like that.
But you have
too.
our-
So you
you
once in a
made the
lifetime, you
migration
don't have
with
to
that.
touch
It
it.
automatically starts.
Like, I know you're gonna have to create a lot.
Okay,
But
But
not
this
doing
is-
anything right here, but.
Well, this is kicked.
oh, it doesn't like matter.
It does matter. And also.
Okay, so you're already logged in.
Well, yes, and then just, I would just delete this.
If you make a start call migration.
Oh, wait, contract.
Just caution in migration. And the way to do it is npx truffle migrate. And specify the network.
Delete.
Okay, so we have. Not on this one.
I've never seen this one, sir.
I don't know, I'm not exactly sure.
Oh, it looks like people are saying the fix is to reinstall your VS Code.
So VS Code 3.
VS Code, well, it looks like at some point after updating, somebody's commented on here after updating Mac OS, Git lost their passphrase with their SSH key. So the only way to fix that is just to reinstall VS Code because it'll give you a new key or it'll regenerate the thing or something. I don't know. The SSH.
Yeah, you can get it from GitHub.
Yeah, you
know, but you're not supposed to do it explicitly for VS Code. It's an OAuth.
It's OAuth, yeah, but
So it should generate the key for.
yeah. But I'll do that. So, I already installed them once. That's ridiculous. Yeah. I'll kick out.
What if you just added it right?
You did what?
I deleted my desktop. I have no desktop.
Why?
Because I was clearing up like some storage.
Yeah.
I'm sorry, I don't, it's off my head, I don't know. That's true.
I mean, you could literally just put it in like the exact thing you start saying like.
So, I mean, you're trying to do this through.
I know it's
just
missing your.
so like.
secrets, but also
But.
Then it's not a
unit,
then it's technically unit testing,
So.
one thing, but I just don't remember how to put it in without
That's not very common actually, to have repeating phrases, not very.
So you put it in before,
There it is, okay, password, that's gonna need to be in,
like, first one.
I don't know if that's your password.
Did you do SSH add?
I haven't gone that.
I
far
did
yet,
it,
no.
but it didn't help.
Put
Okay,
it in right here, the start campaign, where would you put it in?
You can put it in there, yeah.
That's it.
You can put it out
And
of
then when you, if you verify, it's npx. Shuffle run.
I'm gonna go, just let me know if you.
And then the name.
Gotta figure it out, I can look at my stuff,
Um,
look at that, alright, sounds good.
And the network address will pop up.
so those are two changes down, one change up, so,
So now we're verifying.
what are the changes that you currently have on GitHub that you don't have? Did you upload?
Next, all these boxes.
Why is it saying there's two down, one up? I only closed it. Didn't notice on there.
I think when you did it with npm, maybe it didn't stick.
This is 105.
I don't know if npm is like that. Now it should just command click.
And you want,
This link.
you want this.
Yeah. Yeah.
The bot updates.
It's actually my friend's laptop.
Jack, did the GitHub bot re-add some auto grading stuff recently?
Which one?
The just GitHub Classroom bot, did you make any changes?
Which one? 5?
5.
I don't think so.
This is showing that there was initial stuff created on his.
Can you check what was updated?
But I'm having issues.
Zero
getting
change
the-
files.
And the to work. Specifically with this part. Yeah, I went here.
Okay, so what I'm gonna recommend then is. GitHub's doing something.
That's very common, isn't it?
Okay, so what I would say is, so let's go ahead, so did you just edit the test file, is that everything for now? Okay, so what I'm gonna say is go ahead and just copy your test file into a new folder, just copy it on your desktop real quick, and then I'll help you just figure out your cache source on this repository.
Also not sure if I did.
Just straight up copy everything into a new file somewhere else, that way you don't lose your progress. If that works. Anything else? Perfect, that's fine for now. So, okay, let me just. This might not. Also probably just. Yeah. I don't know why it's confusing as that, but we can figure out how to take. Give on the.
I mean, everything got pushed. So your whole, your just copy is fine, it's here, all your data is here now. I'm gonna wait to see what the GitHub action.
So I did the
This should.
like
running
fix up
code,
homework 3 and then
actually
actually send
runs.
it, and then when I was looking at homework 4, so that whole like.
I don't know what was going on.
I had it
Yes.
worked.
All I can say is
Fixed
that
out.
keeps for now. It's the simplest typing git push, git
Oh, I see,
pull,
right.
which is basically what. what's going on there. I did.
Yeah.
Yeah, I don't.
So can you
I've
open up
never seen that
homework?
there.
That was
I'm not
free,
sure,
right?
but according to what you
One
want
that's
to
not
say,
typing.
it's likely somebody.
But
is it the-
Does that make you go to command every time you try to commit?
His was, his was giving him an error, not letting him push or pull or anything, saying that there was an issue with his keys. And
But what if you just re-clone the whole thing?
it's fine, we got it,
How do you fix it?
I don't know.
Yeah, I just had to do like in the command line, git commit and
It was saying that.
Yeah, your VS Code should be linked with that, it should just be basically running those commands in the background anyway. But I don't know, in this case, there was some sort of config issue. Also for sorry. Truffles, I don't remember the exact. Jack, what's the command to deploy?
MP, okay, it's
NPX.
npx truffle migrate dash network COVID.
Gotcha, thank you.
I want to ask, saying. You have to see a thing, or scan
Which thing you use to search? Either your you can probably search, Jack, can you search from the hash? You can scan.
Yeah.
So, okay. You can probably-
So these should not be some.
You can also do the contract address as well. I know you can search for that.
That maybe be an
Which
I
you
change
code
it or
another scan,
But for some reason, well, are you sure? Because I don't see
Oh,
any changes here.
Gopin.etherscan.io. And then,
What do you, I mean, I haven't touched it, I didn't, I haven't updated it,
transaction
since I
hash.
submitted it, and
I know, but
Which-
whatever is on GitHub is newer than what you have. local.
The URL.
I have no idea. I haven't really gone on homework 4 until yesterday, when I went to fix it.
So I suspect.
So Eric Dunn called
It's
multiple
not
times
even-
to test.
I don't know what you did, but
Oh, maybe, I think what happened was I didn't push I just copied the code onto GitHub and then updated it, so maybe this didn't get updated.
so you specifically updated this.
No, I didn't touch that file, but I was saying,
I know, but it says you did. Yeah, so that was a problem. And I don't think any of this.
Donation received, where does
so I
that-
saying I put that in there.
You use it here, but I don't see, it says it doesn't exist in your contract. So is there something that didn't get copy pasted?
That should be fine. Also.
Okay, so I should just, hit, like, message you on Piazza for homework 4 or whatever.
That there, if you click. just click
And then also,
Wait, hang on.
Grid over here,
Create migrations.
this event.
Okay, never mind. Yeah, let's wait for, I think this is fine. Pretty sure that's.
I don't know how it would happen, but
Yeah.
I just,
Yeah, I think it's gonna work. It's gonna take a bit.
sorry, that's fine. And then just for here, like where do I add in the revert there, like
That
to
was
the,
solve, but
like when it says functional tests,
full
these
file
two
path,
reverts
yeah.
should be triggered and caught.
Yeah.
Like where are you supposed to write that? Like, is that supposed to be its own thing, or its own like it section?
No, so look at,
Did you compile it?
so look at for grading script. It says withdrawal overdraft should fail. So basically, I'm trying to do something that's not, that you're not supposed to. That's front contract supposed to, not allow, and I'm catching this referred to.
Which section is this?
Very end.
Or to be ver-
Yeah, so basically, the gist of it is you, and you can incorporate this into like another it as well. So
So
basically,
you just add,
so
to
basically,
revert
in-
it onto something?
yeah, so in the flow, so basically, that function, you can see inside the expect, I'm calling something that shouldn't be allowed, and I'm expecting it to be reverted.
I need to start here first. So I just basically just grab what I had from.
okay, so if it doesn't meet, so just add to be reverted on two different things, or should I really just add them?
You can have it needs first and then just.
Well, should everything be reverted?
So I use.
Okay.
This.
Yeah.
Yep.
Start.
So I got my test screws.
And then the error.
And I heard research that Chase that you should start it having.
Yes.
Campaign is.
Yeah.
Here reverse campaign.
Yeah, start.
This Are you sure it's giving you this one, this line or this?
Yeah, because,
Campaign ended is the one correct.
Yeah, because you never started, and what's the value? 1 ether, so that's 1 ether, but because you never started it, you never put any money into it, so it'll be 0.
Yeah, I was trying to see if it gave you a line numbers. So is this how you started? I don't think that's.
Oh, Okay, sorry, you started it, but you never put any money into
Okay, so you do the.
I'm just a little confused by this error. I'm just creating a testing script for V2. And it's saying like can't
Oh, because you have to,
figure
you have to run npm run build,
Okay.
yeah, because you have to generate types.
I just want to see. Okay. So you can see this is, let's go back up to the last one.
I did all that for V2.
Another one, so it's expecting one you gave. it to
Generating your new typing.
This
So
value.
now to go back. V2 tests. Yes.
How come this would allow underlying grad? I
So
just copied
it
it.
was saying that expected.
Yeah, sometimes what happens is, like, if you see an error that has something to do with
One argument, as to, so
like-
this is your issue right here, these were.
unsafe assignment of any, you just close VS Code and reopen it.
I'm not very sure if you're pretty close to the text, yeah, that one.
But it says that this is. So why does it say this is here? This is.
I was working on my PA and our class group, me for 201 was like, oh, just go watch this YouTube video, watch this YouTube video. And then
Honestly,
we had CP.
Yeah, it's my YouTube video.
Very
That's,
helpful.
I'll do that too. I'll,
How do I check for?
that aside, I don't know, so it's failing, there's probably another reason it's
Yeah,
failing,
check.
but in this case, sometimes the error messages that'll pop out if you don't want to define.
Okay.
So I would
So
say
the
try
way
to
to do
fix
it,
this one
first
first.
look back on homework
error
4.
message, if it does, it's
Sorry,
there's
yeah,
something.
homework 4's test scripts.
So how do you fix that in the changes?
See how I test.
You have to
draw
change the
here.
R's for being passed
And
in,
how
so
I
I don't
pass-
know, I don't know off the top of my head what the correct way, or what
So
the
you get-
correct arguments are that you're supposed to pass it.
You can get it or transfer, get it after transfer, see what's.
So once again, now I can interject, just because I don't have any answer, but.
Another one.
Come on, Jordan.
Hey, you know what?
It's fine, I don't know how to write React either, so.
Yes.
So so I just grabbed this from the code I had that started the campaign. And so I'm trying to do like the thought process, to get campaign ID first and then start a campaign.
I see the problem. So the problem is, let's go back to a smart contract.
Like the original one.
Yes. So scroll up. to the top. Okay. Campaign ended expects 2 arguments, but in test case, you're only given 1. So that's this problem. It says you expected to have this one to have 2
And a
arguments.
certain amount of fundraising
Yeah.
funds raised.
Yeah.
So can you put in any number?
No, so that's like actually how much got raised. So that means this means the campaign, this campaign ID campaign ended with
Yeah.
this much funds raised. So it's not any amount. It's how much that campaign is. And you're able to get it by, what do you think?
Well, I have value in here, right?
So do you have a
The
total of 12
test.
tests with the 2
What that?
functional tests?
So fundraise is
Yes.
256 and it's a certain
The functional tests, you just go through the entire contract.
so the campaign. And
Yeah, but you see where that value is stored in the struct,
okay,
and you can get that struct out. And you can get campaigns, right? Because how much is raised is stored here. Right, and you can get this struct by using this. That's right, by this. And then get it before you end it, or get it after you end it, and then check the value against the event.
okay, so then I have to add the test that I have for get campaign too.
Yeah, well, if you already tested it before, then you can just use it directly.
But it would be after I end the campaign.
Yes.
So then you get the so you get campaign and then make sure the value equals.
Yes.
Did I see the, if I
Yeah.
go back to that.
So when I'm testing, like.
Yeah.
With the deadline and everything, I need to pass in the deadline. If it's block, I think got a number, like how big is that number? Like if I wanna give a deadline, like it's a short number, like what a good example is like. I feel like it's,
Yes.
I feel like 10 might be too small though. or something.
So you can get the
So if
current
that's the
block
case, can you put those in credit?
by doing,
Jack, homework 5 Wednesday, you said?
Yeah.
Due date? Oh, I see. You got,
take a look. I'll make it for something else right now.
versions should start out things set up we're going to do NPM CI.
Do yarn install frozen log file. npm send log weird issues.
So what if npm CI, you have to do that every time you like load up a new,
Yeah, just do yarn instead.
yeah, and then do the npm run build test thing.
I still use it, yeah,
Yarn is faster to build.
that's probably true.
Yeah, and also just in general, it's got fewer issues for some reason.
That's also probably true, but all habits die hard.
Yeah. You know, actually cuts our build time in more than half on Fleek, using yarn.
It's good.
Yeah.
Is it doing a different kind of caching or is it, why,
So when it builds, it's able to build in parallel.
that's what it is.
I think it can build 5 packages in parallel max, npms 1 by 1.
What were the extensions we're supposed to get?
Wednesday before class.
Would you?
Were they like prettier or something else?
Oh,
It seems that you all so you see the same stuff. But you start and you just donate all in the same.
All the same.
Yeah. All the same.
Oh, yeah, yeah.
okay. And campaign only takes two arguments, but you're giving it 3. Oh, sorry, it only takes 1, but you're giving it 3. So I suspect you're calling the wrong thing. Are you trying to get the ID or trying to I think you're trying to I'm trying to get the ID. Get something ID. And
Thanks, Joe.
yeah,
Thanks.
I feel like you're trying to do something. So what was I guess your intention was what was your intention? So because you were trying to end the campaign, but then you're trying to end, but then your end campaign had the arguments from get campaign ID. Yeah, and when you get campaign ID, in products, and this thing does not give you the campaign object. I think because you're trying to get the object. So what you do is yeah, so what you were trying to do didn't really make too much sense because you're trying to get the value from the end campaign call, which it doesn't give you any value. But the test down here, you're trying to check for specific things in the campaign. So I'm guessing you're trying to get the campaign struct, which you get by giving okay.
And do you test like the variable part, like
Yes.
and like what do you use?
So if you look at homework 4, let me stop this.